Particle A travels in a straight line. In other words, there's some line it's going along. So particle A is starting here and it's going along here, maybe going backwards and forwards. Its displacement S, so there's displacement, and after t seconds, so there's time. It's given by this. So give us a nice equation for displacement between 0 and 10. So this goes up to 10 here. There's 0. Particle A starts at the origin and passes to the origin again when t equals p. Find the value of p. Well, let's take the original equation. So that means that it passes to the origin, so S of t equals 0. So 8t subtract t squared equals 0. We can factorise this by a t. T equals 0, which we know, or t equals 8. So p equals 8. So this is at 8 seconds when it passes through the origin. Particle A changes direction when t equals q. Well, it's going away from the origin first, then it comes back. Here's its change in direction. So this is when it's q. I could differentiate if I wanted to, so we can do that. We could do v of t equals 8 subtract 2t, which has to equal 0. So 2t equals 8, t equals 4. Or I could just say, actually, this is a quadratic. Since it's a quadratic, it's symmetrical, so this must be halfway between the two. So q equals 4, I could have got straight away. Find the displacement of the particle origin when t equals 4. So we need to put t equals 4 back into this equation, which is my displacement. So now I want S of 4 is 8 times 4, subtract 4 squared, which equals 32, subtract 16, equals 16. It's in meters per second, meters, yeah. Find the distance of particle A from the origin when t equals 10. So now when t equals 10, we can do that. We can substitute that back into the equation. So S of 10 equals 8 times 10, subtract 10 squared, which equals 80, subtract 100, which equals negative 20. So distance is 20. Total distance travelled by particle A is given by d. Well, it's gone first of all this way by 16 meters, then back again by 16 meters, then another 20 meters that way. So that means it's gone. D equals 16 plus 16 plus 20 equals 52 meters. A second particle B travels along the same straight line, so it's velocity. We've got velocity for one now. T is greater or equal to 0. When t equals k, the distance travelled by particle B is equal to d. In other words, if I have to be careful. Let's look at a diagram of its velocity. So 14 subtract 2t. This looks linear, so it's a negative gradient, negative 2 gradient going through 14 on the as a wide step. So it looks something like this, where this is 14. And we can find it's when its velocity is 0, so 14 subtract 2t equals 0. That means that t equals 7, so this is at 7 seconds. And because it's a nice linear thing, I could do the integral. Actually, let's do the integral, or I could find it from triangles. So let's do the integral from 0 to 7 and see how far it goes. Of 14 subtract 2t dt in brackets, because those are two separate parts, should give me 14t subtract t squared between 0 and 7, which is, when we do this one, 14 times 7 is 98, subtract 49, subtract 0, when we put 0 in, gives us 49 meters. So the area under this curve now is 49. I could have done that by doing 7 times 14 and then halving it to get the area of a triangle. In fact, that looks a lot easier. So So we want now to say that's done 49 meters to get to here, and it's supposed to have done 52 meters. So that means if I do the integral between 7 and let's do when t equals k of 14 subtract 2t dt, that must be, so here we want another 3 meters, so that must be -3. So I want the area of that to be -3. 14t subtract t squared between 7 and k must equal -3. So that means that 14k subtract k squared subtract, we did this before, this is already 49 equals -3. So we get k squared subtract 14k, sorry. Subtract 14k equals, just take the -14, so we've got -49, so plus 46 equals 0. That way around, so that's negative, take the positive to the other side. Positive becomes negative to the other side, negative becomes positive to the other side, that's right. Can I find solutions to that? So look for factors of 46, 1 and 46, 2 and 23. 3 doesn't go into it, 4 doesn't go into it. In fact, that's not very nice, so we don't have any nice answers. Let's complete the square. K subtract 7 all squared plus subtract 49. That's completed the square on this first bit. And then start by plus 46 equals 0. K subtract 7 squared equals 3. K subtract 7 equals positive or negative root 3. K equals 7 add or subtract root 3. I've got 2 solutions, and now I need to work out that the K value I've got must be bigger than 7, must be over here. So it must be, so we know that K is greater than 7. Therefore, K equals 7 plus root 3. Let's look at the triangle solution, see if that's any easier. So the triangle solution should be, I know this is gradient 2. So whatever distance I go along there, here, let's call that, what lesson I've not used, f. Then this must be 2f because the gradient is 2. So then I know that the area of that triangle, which is f times 2f over 2 equals 3 is the area of the triangle. So we've got the area of the triangle and this length and this length. That means that f squared equals 3. F equals root 3. So I've just found this length here. So therefore I look at the total time t. So k will be 7 plus root 3. So looking at areas of triangles was an awful lot easier than going a long way around the houses with the quadratic.